All right, I wanted to start off with something that is just a little bit proverbial, like a little bit in the peripheral, not really. Um, it's oblique, but it's just this idea like money versus power, essentially in a lawsuit. So uh, the idea is if essentially, I would say, because Google actually monetized one of my videos without my consent or anything like that. I don't even want to get into my settings or anything. I don't have, I don't have 1,000 subscribers, okay? And like they monetized like one of my videos recently that got over like 200 views, and I was on another I was browsing like music, and there was this dead rapper who had one of his who had one of his CDs uploaded, and it was monetized. Not to mention, like it was like this black rapper from Brooklyn, New York, and it was like about racism, so it had Nazism symbolism, and it also had KKK in the title. And Google or YouTube, they had monetized it, and like the guy was complaining like I didn't choose to monetize this. I didn't monetize it. So I mean that was the only other time I saw it happen, but I'm sure it's happening a lot. And I never monetized my videos. I just wasn't going to look into it. If that guy was saying that it monetized his video, then why wouldn't it have monetized my video? I guess I can still look into it, but my point is, like in this lawsuit scenario, it's a money versus power thing. So essentially, like if you have any money at all, because you can't really get someone, like the idea would be to get someone to commit a lawsuit on you to gain uh not popularity, but to gain like sort of public approval, to sort of make a scene in the meta political spectrum, to say, to demand things. But I'm saying money in this case does not equal power. Money, essentially, like if you're a homeless woman, you might lose like every time a man does something harmful or something like that, a homeless woman would lose in terms of like the lawsuit and the case and everything, because she's homeless. She doesn't have any power. Like essentially, she doesn't have a place to stay. Things of that nature. Children, animals, they don't have power. Okay, they don't have power. Let alone do they have any money. So we think that money is this. That it like somehow gives us more traction to the big dogs, but like the big corporations like Google, who obviously own YouTube, they're not giving. I mean, they're not like they don't care about the money. They just know that they have power. So if like someone wants to, because there used to be a lot of lawsuits against Harley Johnstone, Durian Rider for just different stuff across YouTube. Like there was a lot of there was like a lot of sex scandals or things like that, or like I think some parents like try to sue him for for hurting their children. That might not be true, but I'm just saying, there was like a lot of stuff. Like riding bicycles and stuff. Like somebody got hurt riding their bicycle, and he didn't want to get sued for that. I'm just saying, I don't think that happened, but the sex scandals were real, and but essentially they just thought that they could do it with money. But the thing was, you find that you're just paying for like a lot of lawyers, and essentially if the other party, like the so-called perpetrators, if they have the same amount of money, then it usually just gets settled in court, or not settled, but it'll just get stalemated, and it won't go anywhere because they've also paid for their lawyers. So the defendants So the defendants don't want to keep paying for their lawyer, and they just say, "All right, what the hell?" Because that person essentially had enough power to defend themselves. So I'm saying it comes down. I mean, you can say it starts with money, but when you're talking about like these lawsuits on YouTube and all this stuff. Um, I mean, this doesn't have anything to do with like this welfarist propaganda or whatever, or yeah, like this welfarist propaganda in this like capitalist society, like this Marxist society. Like this Marxist stuff could really be um, essentially just the welfare state, um, just because the arbitrary plan might just be, well, America's always going to have more power, meaning yeah, China has money, like China imports all of our stuff, or China exports all of their things, we import all of China's things. um, but at the end of the day, are we going to have more power? Like, are we going to have more military assets? You know what I mean? Like, power is just sort of more assets. So if the homeless woman is essentially like living in an apartment or something, then she has more assets. She has more power, and that's usually what matters on paper. And so I'm just saying sometimes. Like if you're a minority, it can be sometimes if you're a minority, it can give you that can be an asset. Even if you're a white person, that can be an asset. I mean, so there's different things that can be assets, or people go to church to gain assets, to be able to meet people that are going to be assets for their network and all this stuff. So that was kind of my point. You know, Google like monetized one of my videos. They have more power. Um, you know, and it's not about the marginal like pennies or whatever that will be going to Google. I'm just saying that they have power over the structure and all this stuff, and they've you know, and now basically YouTube has become like a second Facebook, or like a meta Facebook. So yeah, um, yeah. I mean, it kind of just takes me back to the Stalinism thing. Like you can only fight this if everybody's in. Like if all the citizens are in on it, then like we'll fight back. But we'll only fight back if we're not being, you know, if we don't like have food and things like that. So if it gets really, I mean, if it gets really bad, then we don't have food. I mean, so long as we have food, which most people, I mean, most homeless people in America, they die, or I'd say third empire countries, first world countries, they mostly die of the cold. Like they die, you know, like I mean, in terms of being homeless, like they might be really unhealthy, but I'm just saying they mostly die from cold weather, like sleeping out in the cold. But anyway, so yeah, I wanted to get started with like this Melon Transform, and it's basically like people are always wondering why do the physicists that why do they go by curvature? Well, they go by curvature because they call it melon. They call it melon transform, melon transformation. I think melon is just some guy's name, but it's a melon transform, and they basically have what I want to say. I'm not too insanely sure, but it might be like the Lorenz space where they're able to capture like their little angular momentum. They also have it's called angular dependence as well. So they can have if they have like if they have reflective lensing, basically uh, expanding the sun, or expanding the size of the sun, then they can take into account what how much gravitational force, how much gravitational. All right, so basically, yeah, you'd see, you know, you'd see the sun like with like your naked eye from space, and then you use a telescope, and the sun obviously gets expanded. You can see like you can see black spot, like what are they called, sunspots or whatever. You can see all that because it expands. So I'm just saying, you see it at one distance with your naked eye, and then you see it at another distance, and it's 10 times, 20 times larger because of the reflective lensing. Now, the reflective lensing they do, in my opinion, they do these, I guess, equations, these transformations, but they understand the dependence of the actual gravity. Um, all they have to do is figure out one, like, I don't know, just the difference of the width, maybe, and they can understand the expansion, and then they have this Melon transform. It's either the Lorenz space. I think it might be the Lorenz space, but that sounds like magnetism as well, so I'm not really sure. But they understand the product of their expansion. So then they have this Melon transform, and then that would be their angular dependence, and their angular dependence is basically just both sides from one point. So they're just understanding one point on the scale and how much it expands, probably by using just like some gravitational equations. I mean, it can't be. I'm just saying it can't be that difficult. But they call it angular. This basically this Melon transform can be angular dependence, and that angular dependence can give them what they need to be able to understand like what they need to get to figure out the difference. So the difference in size and why it expanded and how much it expanded. And yeah, so they plug these things in. They just have like inputs. They just have plugins and inputs and stuff like that. And yeah, so and then this would also give them their memory effects, because as soon as they have like this angular um, they understand this angular dependence through the gravitational lensing. They can get do their Melon transform, and then they have both sides of basically this like space that they would expand with their telescope. But they're not expanding anything that they see. Everything they see looks just expansive. It just looks expansive because of the reflexive lensing. But if they zoomed out with their Hubble telescope, they'd be able to see the actual images that they're looking at. So they'd be able to understand like these angular dependences of the galaxy or the black holes or whatever they're looking at, like the nebula or the what's the big one? The whatever that star is, like a nebula star. I don't know. Like supposedly the first stars. So yeah, so that's how they get their these memory effects. They get them through equations, and by understanding like if you look at one galaxy in space all the way zoomed in with your reflective lensing, okay, because these mirrors can definitely reflect. Okay, all they really have to do is just like the mirrors. I don't think they can cross like the 90-degree mark. I think they just keep reflecting, because as soon as you cross the 90-degree mark in a reflective lens, okay, straight up and straight down, that would be 90 degrees, then it would become refractive. And essentially, refractive telescopes, all they do is just make things more high definition, but they're not looking for depth of an image. They're looking for width of it, pretty much is what I'm saying. So they keep that. So they don't want the definition better. They want to actually be able to see further. They might want some definition, but they can also Photoshop or do whatever they do. So I'm just saying, because that's definitely what they do with the Einstein ring. The Einstein ring, you should be able to see like at the beach or something, and like on a clear day. So, yeah. They don't want the angles of their mirrors, the reflection of their errors to be able to mirrors, the reflection of their mirrors, not errors, but mirrors to be able to cross that 90-degree mark. And essentially they want to be at like 91 degrees all the way to like not 180 degrees, but like they want like a 45-degree angle on the reflective lens. And so that angle, the reflection, if it's 45 degrees and it's a and essentially if the telescope is like the size of me, like 6 foot by 6 foot or something like that, then yeah, it's going to be like really expansive, especially if those mirrors are pointed at like 45-degree angles from where you're actually looking. But even that, you're still already expanding the width because you're looking into the telescope um, from a certain angle. So like, I mean, you almost have like it's like almost greater than, it's always going to be greater than 90 degrees is what I'm saying. Like the width of their actual, like magnifying glass on space or telescope. But yeah, so they're using that reflective lensing. But they just have to figure out, they have plugins and all this stuff to be able to figure out these angular dependence, okay, because they're never looking at the exact picture they're looking at. They just zoom in on one piece, and then they zoom out, and they still have that one piece, and they have an expansive circle, and that little piece turns into like a little itty bitty speck on their picture. But then they can figure out the angular momentum of that picture. And I would say that they have a gravitational constant, and they have a speed of light constant. And if they don't use those constants, the gravity and the speed of light, then it'll essentially mess up their math. In my opinion, it'll mess up their uh, their angular dependence. So it's like very important that they sort of barrage this this speed of light and the gravitational equations, because I would say that their theories don't work without them. Well, not their theories, but their mathematics doesn't work without them anyway. Um, and then it's just like where they're colliding photons, where they're shooting lasers at each other, and those lasers, or the light, the photons, the light, the rays of light are colliding with each other. Um, so they collide at each other at a certain point, and then at that point they kind of like just reflect and reflect and reflect and reflect and reflect and reflect. So it's kind of like that. Um, it's kind of like they connect at a certain point at like a tip, and then there's just like this reflection, like sort of like a like an all-seeing eye or something, where the reflection in the background is just reflecting up. You can see pictures of it, and that's what they have computer graphic integrated images of, CGI images of. um, but it's still supposed to be realistic. I mean, they can't see it with their naked eye because they're really strong lasers, I'm sure, but they just can't see these reflections with their naked eye. So they say that there's these reflections, and they run the exact same experiment over and over and over. They get the same expressions of the photons, okay? Because photons will realistically, they will reflect off of each other, but they're saying that now we're dealing with the subatomics, so we're dealing with the subatomics, with the quarks, and with this cosmic soup. Okay, so they call it the cosmic soup, and the cosmic soup is what is always perforating out. Okay, so all of these things are like all the subatomics are strung, or you could say yeah, strung or like glued together. I mean, they have like a gluon, a muon, and those are essentially connecting the electron, and then there's neutrinos, like these sterile neutrinos, and all of those things are moving. The subatomics, all those things are moving basically in cohesion with the cosmic soup, and the cosmic soup is what is like essentially uh, doing this. It's doing it's causing the movement. Uh, so I mean, that doesn't seem like they have anything more than that. But if they have like a certain degree of movement somewhere else, then they'll create a new quark. Okay, so the quarks are the muons, gluons, and neutrinos, and they connect the electrons. And essentially, there is yeah, the cosmic soup is what is going to cause those to move and everything. So they're saying that that's not the um well, I guess essentially that's the anti-gravity particle, or the anti-gravity bit in dark matter, and everything. So everything on the ground, like essentially their theory would be that everything on Earth, like everything earthbound, would essentially have more. Sorry, it would have less cosmic soup, because everything is tighter, is like more night. Sorry, is more, yeah, it's titted. Jesus Christ, titted. Knitted more tightly. Okay, knitted more tightly, and because it's so tightly knit, like on the ground, that's why you have structure like solids, and that's why you have solids or H2O or things like that. But then once you get to where there's less and less hydrogen, or no oxygen, or just hydrogen and helium, I mean, it's I guess 90% hydrogen. Essentially, the idea would be is that there's a lot more cosmic soup. Okay, so a lot more cosmic soup in space than in Earth, because of the elements are different. Because the elements are pretty much the only elements in space are hydrogen and helium, and the elements on the ground are there's like 200 elements on the ground. Um, but just air, H2O, for example, is two hydrogen, one oxygen. So even that's going to have less hydrogen in it than sorry, that's going to have less cosmic soup just because, yeah, there's more hydrogen. So you only have one hydrogen in space and two hydrogen on the ground, but you also have oxygen, which is going to have a lot more electrons, gluons, muons, neutrinos, etc. So there's going to be a lot less cosmic soup on the ground. So it's just that's kind of a cop out in my opinion. But they say that's kind of like their anti-gravity notation runoff, their anti-gravity runoff, because yeah, they don't have um, or run on, I should say, run off or run on. Like, yeah, they don't have anything else, so they just use the cosmic suit for anti gravity. It's like they run on. And then this whole drift thing. So the drift thing sort of reminds me of the Faraday paradox, and the drift is just this idea that when you cut the electricity, when you actually cut the electricity gets inverted back into the stream, and the stream, or sorry, yeah, the electricity gets, or like the direct current gets cut off, and the electrons or protons keep moving, or they stabilize the environment basically through a drift. Or not only that, but they drift against the direct current when the direct current is let off. So when there is electricity, they have to drift in basically to stabilize like the electricity or something. So if there was a lightning strike, lightning strikes up. So that means that electrons and protons, they would be drifting towards and causing that static electricity before the actual direct current of electricity was able to shoot up. I'm saying it's more of just a nuclear fission. The nuclear fission causes it, and when the nuclear fission actually is able to fuse, that's when the lightning strikes, or that's when the electricity that's when the watts are used and all that stuff, or the jolts or volts or whatever. Um, so yeah, and then you have I don't know. I wanted to get into taxonomy, like for evolution, and taxonomy is just going to be like taxonomy is kind of like the distribution of biodiv, like why did these species go there? Why did these species go there? How are these species able to survive there? Um, so it's something that is a little bit it's something that kind of like is negated by our situation today, since it kind of like, well, we don't have anywhere else to go um, except for Mars or Jupiter or the Moon. So we're like in this weird taxonomy situation. So the taxonomy is kind of like, we can kind of see that it's um, sort of peaking, I would say. I mean, I think essentially it's just because humans have humans have kind of industrialized and everything. But so I'm not saying there's been a lot of change in taxonomy. But yeah, I don't know. Some of the stuff, like, used to hear that like there would be no animals in the oceans by 2040 or 2050, if not 2050. And yeah, these things are just becoming, I don't know, like a little bit like, it's like, I mean, it's scary if it happens, and it's scary if it doesn't happen. I mean, especially if it happens like kind of like just because we want to drill more oil. If not like, I mean, we know we're doing it now. So I mean, it would just be, I don't know, it's just scary that like nobody's really, okay, we're forcing species to extinction, but we're not really going to have like a conversation about it or anything like that. But anyway, yeah, so I wanted to kind of get into taxonomy, but taxonomy has kind of been like, it seems like it's kind of been neutralized. That's why it looks like a lot of the nine planetary boundaries, if not all the nine planetary boundaries, have been crossed. But it's like, well, it doesn't really matter, because it's like we're still moving in one direction. I mean, so I mean, we're just either, I mean, we're just either causing more harm to the environment or causing more harm to ourselves later. Um, so that's like a weird taxonomy, taxonomy, like, you know, derivation of all this. But yeah, and then and there's, because we're just talking about like apex humans, and humans being apex predators? Like, are we going to, like, you can think evolutionarily, like if it's just you and a and an alligator like on an island, essentially, like, I mean, even at that, I mean, I'm just like, when I was saying reptiles like alligators or crocodiles, like these things are more evolutionarily inclined, like they're more evolved. Well, yeah, they're more evolved to the extent that, we, to the extent that, like, we were incubated. So if we were incubated, then an alligator is going to evolve, like, sorry, live longer than us, or a snake is going to live longer than us, because, yeah, we can't go a certain amount of days with food. Um but humans are sort of apex in that, like, sort of like it sort of becomes that conversation with what was that, whatever. Humans are more like evolved in that, like, yeah, they can use tools and everything, and they can use like, that, like, their imposable thumbs and all that, and then we can create weapons. So essentially, like, a human or homo sapien would be able to, like, go and create a spear, and that spear, and make it a lot easier to take out the alligator. So, and then it seems like we also still have that, like, ravenous like effect on ourselves. Like, so essentially, like, if we are starving, then we do compulsory, like, there is a compulsion to be able to, like, get food and obtain food. At least, like, that's what um I've kind of examined, maybe, I don't know, in movies or whatever. But we still have that, like, Darwinian, like, urge to survive if we really do need to survive. Obviously, like, we have a flight mechanism too, where we need to run away. But if we know that we need to kill that crocodile, then, we'll just make a spear and try to kill that crocodile. Um, so that's a little bit like of a different conversation. Like, apex humans are just the apex predators. Um, but in the long run, like, I mean, that is kind of, it is like, I mean, because the real apex predators are like birds. I'd say, not just because they're like, I think there's like some sharks and some reptiles that are very like, very close to their Jurassic ancestors, if you will. And then birds are supposed to be in that birds are supposed to be in that category too, where they're very close to some dinosaurs. But if you think about it, it's like, yeah, well, they could be like, vultures, or like vultures, like, never miss a meal. They're always there, and all they really do is feed on roadkill now. But I'm just saying, so there are some interesting, like, epochs, like, to examine. But yeah, it's going to be, like, really difficult to say, well, we're not going to be able to like we're not going to be able to, like, kill every single species on the planet, like, if we really have to, unless there's like species like species of insects that actually um that sort of actually, like, give, I don't know, homogeny to like nature, like, like they pollinate and all that stuff. Like, I mean, there might be some insects that survive a little bit, but over time, like, our agriculture could just get too fucking bad. And yeah, we could really have ourselves in just a situation against other animals, and most likely we would be the apex predator in that scenario. So that's pretty interesting. Like, you don't know how these, like, and that's essentially when power would not matter. Okay, power would turn into more of a natural power than essentially like a corporate power. So if corporate powers fell, then we could have, like, more of a natural power, and you'd have to be a survivor. And essentially, money, whatever like money is in the future, like, it would actually have more leverage. Okay, it's talking about leverage than actual power. Power being like corporate power. So because your power would have to come from surviving, and your essentially, yeah. So your power would be the real leverage. Like, there could be bandits and all this stuff. but your money is what would really matter. And in terms of money, it'd be like trading and things like that. So this is like really, these are really far out, far fetched, scary scenarios. But like it's just thinking about what's going to happen when this banking system fails. When this banking system, and so like when the Federal Reserve banking system actually fails. So yeah, I do want to get into that, but yeah, just Melon Transform, yeah, all this stuff. Yeah, I didn't. Oh, the tachyon. Oh, so the tachyon energy is like this living force, just like the kinetic energy, and it's just called. So they're calling it tachyon. Also axion. I don't know. I think axion and tachyon are a little bit similar, but yeah, this I don't even know if tachyon is real or if it's like from a show or something, like it's from Star Trek. I have no idea. But because I thought I saw it on like a popular physics channel, but anyway, it's supposed to be tachyon, and a tachyon is just like kinetic energy. It's just like the living force. It's just like the cosmic soup, and that like it's this living force, or they call it the primordial soup, cosmic soup, no difference, and they just want to keep applying some living force. And but I think I've totally uh, sort of buried the Big Bang with like their nuclear fission and nuclear fusion because they can do all those things, but they can't come up with any they can't come up with any realistic wager to say we know exactly how evolution started. We just have every single property of the universe. We even know the universe is made out of living force. We just can't even like recreate evolution, or we can't create a clone or anything like that. um Especially a clone, like underlying clone, but so they can't do any of that shit. And yeah, they can't do the feeling computer, the heuristic computer. They just have hubris. They're just really prideful assholes. And they're really lazy about telling the truth. Well, they don't tell the truth, and they just have a lot of hubris. um a lot of hubris in trying to create their heuristic computer, which they know is not going to work. They can't create clones, like I said. They can't. All they can do is do stem cells. So maybe I'll try to get into stem cells. From to my knowledge, it's not really anything. Stem cells like growing kidneys and all this shit. I mean, they can't even really do that, or I don't even know. I don't know. They said they were gonna like keep kidneys in outer space because they last longer in microgravity. I mean, Jesus Christ. But anyway, yeah, that's about all I got.